In this series, we're going to go through all the different technologies that power the internet, and specifically from the lens of a kind of a full stack web developer who wants to build things on the internet. We're going to go through like piece by piece and kind of build up the layers as we go. Um, we're going to go through it kind of chronologically. So we'll start out early with just a few technologies, and then we'll add in another technology, and on until we get to the modern day. In this first chapter of the series, we're going to go through the foundational pieces of the stack, the parts that are way down at the core. So first, just a little about me and why should you pay attention to anything I'm saying? So my journey with web development and programming started when I was around 14, which is around 15 years ago for me. I just really wanted to know how do web apps and websites work? I had this really deep curiosity about it. I didn't know a single programmer or software engineer. I didn't have like any kind of adult in the industry that I could go to with this curiosity. So I started teaching myself. And at the time, that looked like going to Barnes & Noble and buying an HTML book, and then a giant PHP book, and then a giant JavaScript book, and going through them chapter by chapter. It worked. It worked, but those pieces of knowledge were hard won for me. It's, I could go through the chapters, but getting kind of a deep intuitive understanding, it was difficult with that path of just going it on my own. But I fell in love with building things. That's really what got me into this field and what has kept me in it for so long. Because I love that feeling of building something and seeing it work and seeing it come to fruition. So since I had, already gotten pretty interested in this topic, I went on to do a bachelor's in computer science. I was a horrible student. I thought that when I did computer science, it meant that I would get to just go build things. But actually, it meant that I had to learn a bunch of theory and foundational stuff. And so what I actually did was I tried to launch 2 startups while I was in college. That was where I spent more of my time. They were both web-based startups, and it was mostly just me. I had some people I was working with for a little bit on one of them, but I had to do all the pieces. I had to do the front end and the back end and the authentication and the database and all the stuff. So I had to kind of learn all pieces of the stack, setting up the SSL certificates, et cetera, et cetera. That gave me a pretty broad familiarity for a college student, at least. And then after college, I somehow got a job at Google, even though I was a terrible student. I was able to just kind of buckle down and focus on that interview prep. And I've been there ever since. So currently I'm a senior software engineer, and I work on a Java backend for the GCP AI support chatbot. And I've mostly worked on backend at Google with a little bit of front end. But before Google, I would have probably called myself more of a front end developer. And so why am I doing this series? When I look back, I think it took me a while to appreciate the value of the fundamentals. Like I said, I just really like to build things. That was what kept me going. And I still think that that's the most important piece of learning to be a developer, is to build things. That's how you really see how things work. But I appreciate now the value of having this kind of mental model of, the whole ecosystem, because I can just kind of hang concepts on that mental model pretty easily. I can add in a new concept. And I got that mental model by just occasionally rabbit holing on stuff. If I just hit something that I didn't fully understand and I had some curiosity about it, I would just go really deep on it, like way deeper than was necessary for what I was working on. And that has been really effective for me, is this kind of combination of build and rabbit hole. And at least in my experience, I have to rabbit hole on something like 5 times before I actually just intuitively understand it. To the point where 6 months from now, somebody can walk up to me on the street and ask me about that topic, and I can tell them everything there is to know about it. That's the point I get to if I rabbit hole 5 times. If I've rabbit holed on it one time, then I'll think I know it, and then someone asks me to explain it later, and I'll realize I actually don't know it. So my goal here is to is to knock out rabbit hole number one for a lot of these topics on you and give you the first primer on it and get, those neural pathways just forming a little bit. And you're going to encounter these things again in the future. And you'll know where to start looking, where to start rabbit holing. You have to do the rest of it on your own. But I can get you primed. That's my goal. Okay, with all of that out of the way, what are we going to cover today? So today we're going to look at the three fundamental pieces that the web was built on, the internet as we know it. These are the only three things that existed in the very beginning. This is what was launched as the original World Wide Web as we know it today. And so why go so deep on these topics? These three in particular, they feel really simple, but especially working at a place like Google, where the infrastructure and the architecture is like so insanely complex. I have found time and time again that even though these things seem simple, you will encounter extremely complex usages of them in the wild. And if you have a really clear mental model for them, then you can sit down and you can untangle those really complex instances bit by bit and figure out how they're working. But if you don't have that mental model, you will not be able to untangle it. You just won't. If you only understand HTTP at the depth of this is the way that my app talks to my REST API, you will not be able to untangle those things. So that's why we're going so deep on these things, even though it feels like you can master them right away, right? You just explain it once and you get it. It's actually not. It's not that simple if you want to understand it at a deep level. At the beginning here of 1989, Tim Berners-Lee. I knew who Tim Berners-Lee was before doing some of this research, but as I really researched everything that he's responsible for, holy shit, this guy did everything. It's crazy. In 1 year, this guy comes up with HTML, URLs, HTTP, builds the first web server, and the first web browser. That's a lot of the stack right there. That's a lot of it. We added on a lot later as well, but man, this guy really pushed the ball forward in a big way, and released it all with no license, just completely open source. God forbid if this had been developed at Oracle at the time. Who knows what the web would look like today? Probably not like it looks today. So yeah, we owe this guy a lot, and he built all of these things just on one key insight that he just kept unraveling and kept unraveling. Before we get to that key insight, let's talk about what the problem was that he was facing at the time. So he works at CERN, which is the organization with the Large Hadron Collider in Europe. He works there. It's underground all day long. And they're sharing documents for academic purposes using the internet at that time. That was kind of the original appeal of the internet, is different research organizations could host their documents and you could share them, or you could access other research organizations' computers and things like that. But even though they did have the ability to do that, it did not look like what it looks like today. So first, let's just look at how would you access a document back in the day. Okay, so here's what you might have done. This is one of the ways that you might have accessed a document back in the day. So let's create a temp directory where we're going to put our document. And then there's a thing called FTP, which is the file transfer protocol. You can install a program called FTP on your computer, and then you can connect to some FTP server. Here's, hang on. I think I got it backwards, ftp.gnu.org. Here's one publicly available FTP server that I found that still exists. So you boot up your program, connect to it, and now you've connected, and you can kind of browse the file system. So let's say that we want to download this README file right here. Do get README, and we downloaded it. We've done it. So now if we look at our local file system, there's our file right there. Okay, so like I said, you can technically access documents on other computers, but it's not that easy. And here's the problem. you had to know exactly where to look, right? So what ended up happening is if you wanted to get some research paper, you would have to go and find your coworker that wrote the research paper and say, hey, how do I access your research paper? And then they would explain it, and then you would go follow those steps. So it was not creating this kind of, open, just constant sharing of information environment that it was promised with the internet, right? So this is the state of things that he's walking into. Okay, so we looked at some of the pain of the existing way of doing things. Now, what Tim Berners-Lee brings to the table is he has this key insight about documents, and that is that they are related commonly, right? Like a research paper might say, I was influenced by this other research paper, but that's not represented in the system in any way. What we really need is a system that can represent these relationships and allow you to traverse along them. If you have that, then you can start from one document and you can get to every other document that's relevant to it. So this is the vision that he's trying to realize as he sets off to build this next set of technologies. And he comes up with this concept of hypertext. So we're all familiar with text. That's just the text of your document. He defines hypertext as something that contains connections to other texts, to other documents, and allows the reader to navigate between the documents in a non-linear way. And this term hypertext is going to come up. This will be part of the HTML acronym, part of HTTP. So let's just think through it. If you want to connect two documents, what pieces are you going to need? Well, the first piece you're going to need is a way to refer to a document, right? A way to say this is the fully qualified location of a given document, and that's where the URL comes in. URL, you can break it down into 3 pieces at this time. Later on, additional pieces will get added on, but for now, you have a protocol at the beginning, followed by a domain name, and so that is pretty much going to represent like the server that is hosting this document. Which computer does it live on? And then you have the path to that document on that computer. Those are the 3 pieces. It's pretty simple. Okay, we're going to talk about HTTP next, but first, we're going to do a quick aside on TCP. Networking is a big area, a big topic, so I'm just going to give you the SparkNotes version here. But what you need to understand before we look at HTTP is that HTTP does not connect you to another computer. That is not within the scope of HTTP. That is handled by TCP. And TCP already exists, in 1989 when we're going into this. So what does TCP give you? TCP lets you establish a long-living connection to another computer and allows the 2 computers to send messages of data back and forth on that pipe, on that long-living connection. And so it's key to understand that this is not a single request response thing. This is something where you could send 2 messages and then the other computer could send you 1 message back, and then you could send 4 and they could send you 2. Think of it like you call your friend on the telephone and you connect to them. And that phone connection, that is TCP. It's the thing that you guys are talking over. It just stays alive until you end the call, pretty much. So that's the rule of TCP. The other fundamental thing to understand about TCP is that it does not know or care what the bytes mean that you're sending back and forth. It could be anything. It's completely agnostic. You could be sending, this could be like game packets for some online video game, or it could be a stream of video or an image or an HTML file. Doesn't care, doesn't know. It just gives you that pipe to talk through. So now we introduce the Hypertext Transfer Protocol. And this is the protocol is kind of a structured way to send bytes back and forth. Since TCP doesn't have any opinion about where you're going to send back and forth, the only way that you can get any effectiveness out of TCP is to agree with the other computer about the way that you're going to talk to each other. And the Hypertext Transfer Protocol is one of those types of protocols, which is like an application layer protocol. And the goal of HTTP is to allow you to fetch resources from another computer. Just to really pound in this concept here of the TCP versus HTTP split, I'll point out that there's no domain name here. I'm being a little bit ingenuous here. There is technically a header called host where you have to put the name of the host, like the domain name, but it's not strictly necessary for it to work. You just have the path to the document on the computer because you're already connected. Like if you called your friend on the phone, then when he picked up, you wouldn't say, "Hi, I would like to call Jeff," because you're already talking to Jeff. You would just start talking to Jeff. So what are the different pieces here? First, you have the verb. This is the thing that you are trying to make, the action you're trying to take. In the beginning, there was only get. That was the only verb because it's all about fetching documents. So you had your get verb followed by the path to the document that you want, followed by the version of the protocol that you intend to use, followed by some arbitrary number of headers. These different sections are split up by carriage returns, which is a \r\n. This isn't like really that important in your day-to-day life. Usually these things will be taken care of for you by whichever library you're using, but just so that it's not confusing, that's what these are. So an analogy for TCP versus HTTP that I came up with is the pizza transfer protocol. So maybe you just decide it takes too long to order pizza, so you have to call them, and then you don't really know what to say first. Do you have to give like your address first or the pizza order first? We just need to standardize this. It needs to happen. It's 2025. Come on, guys. So the pizza transfer protocol proposal is that whenever you call the pizza shop, just as soon as they pick up, you're going to say, "I want this size, these toppings, here's my address, here's my credit card info." You don't need to have any back and forth, no yapping. They're just going to say, "Okay, here's the estimated delivery time." And then they're going to hang up. And that's it. In this analogy, that protocol for what you're going to say, that's like HTTP. The TCP socket here is like the phone call. So you're not going to pick up, when they pick up the phone, you're not going to say, "I would like to call Domino's," because you're already talking to Domino's. This is just a protocol for the conversation that you're going to have. Okay, so now we'll look at, if we put ourselves in the shoes of Tim Berners-Lee, and we already had TCP available to us, how would we implement some of these ideas in code? Okay, for these code examples, I'm going to use Python just because I think it's pretty easy to read the syntax and kind of understand what's going on. You don't have to be super familiar with Python for this, and we're not going to go too deep into this code. My goal here is just to show you that it's not that complicated, really. Like what an HTTP web server is doing is pretty simple. So the first thing we're going to do is we're going to look at the server implementation. We're going to define our host and our port. And then remember that we're trying to serve documents from a computer. So we have to have some folder that has our documents in it. We're going to use the public folder for that. You can see that full path to this folder on my computer is /workspaces/python http/public. So we're going to make a variable for that directory. So if somebody comes in and they request the about page, we're going to give them that file. If they request the index page, we're going to give them that file, etc. So the first thing we need to do is to make a server socket. And we're going to bind that socket to a port. For our server, we're going to use 8888. That is just kind of an arbitrary port number. So when we call this is going to tell the operating system, hey, if anybody sends a message to us, to this computer, that's for port 8888, then I want you to give it to me, give it to this program. And we're just going to run this in a loop. We just always want this to just keep on going, keep on listening, keep on handling incoming requests. Now this .accept call, this is what's called a blocking call. So when we call this, it's not going to return until we've received a request. So the client sends a request, and then boom, we're going to get back a socket where we can talk to that client. We're going to read the first message of data from the client, because that is what the HTTP protocol tells us to do. It tells us that the client is going to send the first message. It doesn't have to be this way. You could have a protocol where the connection opens and the server sends the first message, but that's not what HTTP says. So first, we're going to read a message from the client. And that message, it's going to be in this HTTP text format. Like, that's what the bytes are going to be that are sent along the pipe. So we know that we can decode this to text, to UTF-8, since that's what the protocol defines. Mostly. There's some asterisks there. Okay, so we're going to split it using that carriage return delimiter. And then we're going to look at the first line, which should be something like this. We're going to break out the method and the path. We're just going to ignore the HTTP version because we don't really care for this simple example. For simplicity, we're only going to handle GET requests in our server implementation. And if they request the root path, then we're going to just treat that as index.html. It's kind of a standard convention. So now we're going to construct our file path by taking the file directory that we pointed to in our server configuration, and then appending on the path that the client asked for. Then we're going to try to find that file. And if we find it, we're going to read the file in. And then we're going to construct our response, which will be first a status line, followed by any headers that the server wants to send back. And then we're going to send all of these, we're going to concatenate this all together and send it back in our response. And then we close the connection. So crucially, this is also part of the HTTP protocol. It says that we're going to handle one request, send one response, and then the server is going to close the connection. Okay, so let's boot that up. Oh, I think I already had this running. Hang on. Let's just shut that down and try that again. Okay, so we ran our server. We're bound to that port. And now we are ready to send a request using our client. Our client is similarly simple, so we're going to say the server that we want to talk to and which port. And we have to open a TCP socket to that server. The TCP sockets, they want an IP address. They don't understand this language of the domain name. So first we're just going to resolve that server name to the actual IP address. And this does go on behind the scenes. When you use some HTTP library and you send a GET request, it is going to first resolve that host name to an IP address. And it's going to just kind of take care of that for you. And then it's going to open a connection to that IP address and send some messages along. So now we can get a socket that is connected to the server. And then we're going to construct our simple request. We're just going to ask for the index.html page and send that along. And then we wait. And we wait for the server to send us back some messages. And we have to do this in a loop until the server closes the connection, because it could break that response up into multiple chunks. And then we'll just decode that and print it out. So let's see what that looks like. Okay, there it is. So we can see that our server received that request, and then it found that document and sent back the response. Pretty simple stuff. Okay, so now we have our way to talk to the server, to ask for a document. And we have a standard way to refer to a document. The next thing that we need is some way that we can encode these links between our documents, because that's the end goal. The previous two things were just made in in service of this end goal of connecting documents together. So that's where HTML comes in. And the big thing that it provides is this link tag, which allows you to link to another document. And you'll notice in this snippet here, there's no HTML tag or head or body. And those actually didn't exist in the original version. Those were all added later to fold in some additional features that were needed. So if you just look at it as it was originally conceived, it's quite simple. And this is the key feature, is this anchor tag that lets you link to another document. And if we think about our Python client that we just looked at, we are already part of the way to a web browser. So we can request the document at a URL, we get back that HTML, and then all we're really missing is rendering that HTML in a user-friendly way and giving the user a way to automatically traverse to another document. And so just to demonstrate how simple that is, we'll look at a very simple browser implementation. Okay, so our first version of this client here, it gets that HTML back and it just prints it out to the terminal. But if we just go one step further, then we can create what I've called simple browser. So you boot it up, it's going to ask you for a URL. Let's do localhost 8888, and let's go to index.html. And here's that same exact content, but just rendered in a user-friendly way. And then at the end, it's going to print out the available links, and it's going to prompt you to select a link to follow. So we're on the home page. Let's say that we want to just traverse onto the About page. We can just type 1, hit Enter. Okay, now it went and retrieved the About page, and it rendered that. And we can go back to the home page, and boom. So obviously, this is missing a lot of features and is nowhere near any of the complexity that an actual browser has. But this is the same concept. Like, this is conceptually a web browser. If we look at the code here, it's not a whole lot more than our client code. We have this fetch URL code that's going to do the same thing, just opening up that socket, getting the content, etc., etc. And we've just added this parse and display method in, which is going to parse the HTML. And then just as a simple way to render it in a terminal, I'm going to convert it to Markdown and then use this library, which can automatically render Markdown into the terminal. And then we'll wait for the user to traverse to another page. Okay, so Tim Berners-Lee has his 3 pieces of the puzzle here, HTML, HTTP, and URLs. So he just goes ahead and develops the first web browser. You can see it's very bare bones, it's very simple, kind of like the one that we just showed, that we just demonstrated. It just renders this text right in the main page here, and then there are some actions up in the top left here that will allow you to navigate to different pages. And this doesn't look much like a modern browser, like in any way, right? This looks like a completely different kind of program. But this is demonstrating those initial concepts. And this is not going to catch on like wildfire or anything. This is going to be pretty niche for a little while. Until 1993, when we're going to introduce the second character of our story, is Marc Andreessen. You may or may not be familiar with Marc Andreessen. He is still very relevant today. He is the co-founder of one of the most prominent venture capital firms in Silicon Valley, which is Andreessen Horowitz. And he's a billionaire and also is kind of a conservative. He's one of those conservative billionaire political funders that you hear so much about, right? You'll see him on like Joe Rogan or Lex Fridman and things like that, talking about his, kind of out there Trumpy views. But if we go back to 1993, he's just going barefoot on Time magazine, So why does he become so well known? What does he contribute? He makes the Mosaic web browser. This is the first web browser that the public really latches onto, and that kind of goes viral in the early sense. So what does Mosaic do that is so groundbreaking? The big thing is that it has pictures. But it actually does, it does more than that. You can see that this is starting to resemble a modern web browser. It's got the URL bar, the back and forth buttons. Like in many ways, this innovated and this created the scaffold that a modern web browser, or that turned into the modern web browser of today. So how did it add pictures? What did they do? Well, they basically just declared, there's an image tag now. We have decided there's an image tag. And you can see why this was appealing, right? Because the image tag makes sense. Why shouldn't you just be able to say, an image goes here, and here's a link to the image? And there wasn't any standards body that they could go to at this time and say, please add the image tag to HTML. That didn't really exist yet. So they just decided that if you sent back HTML with an image tag, then they would render it. So it doesn't seem that unreasonable at the time. But in hindsight, we know that this was kind of the first step down this really slippery slope of fragmented web standards, where every browser is just adding in whatever feature they think makes sense. And that makes it very difficult for a developer to make software that works on all of these different browsers. Now, things are much better today, but it is still a problem. Specifically, Apple is a pretty bad offender today. Well, not bad by these standards, but of today's standards, Apple is probably the worst offender. And the big thing that you want to take away from this is that at the end of the day, the browser gets to decide what is valid and what's invalid with respect to HTML or CSS or JavaScript, or whether or not you're using transport layer security. All of these things, the browser has an enormous amount of power in that relationship. And the standards bodies are just kind of putting things out there and hoping that the browser companies will comply with them. And like I said, today things are pretty good. There's quite a bit of cooperation there, but it was not always this way. And in the course of our story, this is going to get much worse before it gets better. Okay, so now we've set the stage of the World Wide Web. The next time, we're going to start adding in the next logical pieces of the puzzle. And this is where it's going to get quite a bit more complicated and perhaps a bit more interesting. So we're going to look at the rise of the interactive web via the HTTP post verb, which allowed you to both write and read from the web, and the form tag, which was the initial way of sending data to the backend. The rise of PHP, which turned out badly, but you may be surprised that it still has some influence in the design and architecture of front-end frameworks today. We'll look at stateful sessions, being able to log in and log out using browser cookies. And then I'll give you kind of a primer on web security versus via certificates and how do those work. Okay, yeah, I think that's about it for the first lecture. So thanks, guys, and I'll see you next time.